Good appropriate time of day, everyone. We're back with the Buoyant Service Mesh Academy. I'm Flynn. I'm a tech evangelist for Linkerd. With me is Cortney Nickerson. Courtney, you want to introduce yourself?
Sure. Thank you so much for having me here
Oh,
today.
thanks for joining us.
Really excited to be here with your community. My name is Cortney Nickerson. I'm head of community at Nirmata, the creators of the Kyverno project. I'm also a CNCF ambassador. I participate in way too many community events, but it's because I enjoy all of them and all of the people.
Story of my
Um,
life, man.
yes, I get looped into so many things. I don't know how to say no, but it's always a good time. So, and here we are with another community-focused event. So thrilled to be here.
And in fact, we are here to talk about Kyverno, so it's kind of handy that Courtney was able to join us. Shocking the way that works out. If you are trying to talk back to us, there is probably a chat function wherever you are watching this, but absolutely the best way to do this one is in the workshops channel in the Linkerd community Slack, which you can find at slack.linkerd.io. I'm keeping a bit of an eye on that. So if you have questions, drop them there. That would be great. And I think we're going to go ahead and get started. The last couple of Service Mesh Academies we've done are things where we went back and kind of did an introductory sort of thing to try to introduce a concept, since our industry is so generally terrible about talking about things for novices instead of experts. And I always go into this feeling like, oh, maybe this will be a short SMA, and then we end up running out of time. So it'll be fun to see what happens with this one, right? So yeah, we are here to talk about Kyverno at the 101 level with Linkerd. We're honestly kind of using Linkerd as an example of what sorts of things you can do with Kyverno in this one. But we will start by letting Courtney talk about policy as code and Kyverno, which is going to be kind of cool. I'll do a really quick intro to Linkerd itself and kind of why you should care about this stuff. And then we will go into the demo. I should have said singular instead of plural there. I apologize. And then we'll come back, as always, to talk about some of the gotchas. I expect that the demo will probably work today, so everybody keep your fingers crossed. We'll find out what happens. This is Service Mesh Academy, so who knows? If you want to follow along, and we hope you will, that's the URL. Kyverno 101 and Linkerd is the directory within the Buoyant Service Mesh Academy repo. The QR code on your screen will take you directly there. I'm going to be demoing with a K3D cluster. It almost doesn't matter, so whatever you happen to have lying around will work just fine, most likely. There's one place where the fact that we're running an application in the cluster today is very much secondary to the fact that the application gives us a way to play with policies. So there's really only one place where we're even going to look at the application. And if you don't have load balancers, you can definitely make it work with port forward. I will also be using Buoyant Enterprise for Linkerd 2.18, and I hope you will do the same. That will require you to get a free Buoyant ID from enterprise.buoyant.io. I promise you personally, we will not take your information and sell it and spam you or anything like that. It's worth it. It'll be okay. If you really don't want to do that, you can also use open source Linkerd Edge 25.4.4 or later. There is one place in the demo where you're going to have to do something different if you use the Edge release, and I will call that out. These are the tools you will need. If you follow along from the source repo, it will check to make sure everything is there. The most unique thing in here is the tree command. If you are using Linux, you probably already have it. If you're on macOS, you probably need to do brew install tree. Just FYI. Don't you love the way there are so many standards and things like that? It's great.
Always standards.
And with that, over to you, Courtney, to tell us what we're doing here today.
Tell you what we're doing here today. That's a great question. So today we're going to be talking about policy as code. And I guess the first question we need to answer is what is policy as code and what do we mean by that? I've become aware over the last few months that there are a lot of folks that actually don't know much about policies in general, let alone what we actually mean by policy as code. So we'll start with the very basics. What we mean when we're talking about policy as code at its core is that we are defining rules for our infrastructure at the same way we define application code. So instead of documenting rules in a wiki or relying on manual checks or having them in an Excel, which turns out there are people who still have them in an Excel that has to be maintained and updated, we're writing them in a declarative format. In this case, it can be YAML or CEL, which is Common Expression Language. These formats are more or less human readable. They're machine enforced.
Wow, more or less is doing a lot of work there with Cell, but
Yeah,
okay.
more or less human readable. It depends on the human, I think, because there are cell lovers out there that think that it's very readable, and there are others of us who struggle a bit more. But
I really am being a little unnecessarily snide there, right? Cell is vastly better than what we had before, which was kind of nothing even vaguely a little bit standard. So I really do like the fact that it is a way of describing fairly complex things that has a chance of working across more than one tool. Um, but please, for the love of all that is holy, if you are writing Cell and you're watching this, line breaks are good things, and you can write Cell in a way that is more readable than a bunch of people do. So please take advantage of that.
this is yes, this is very very true. You can make it more humanly readable. If it's not, then you can work on your syntax.
Yeah.
Um, So in our case, policy as code, we're working in a declarative format, YAML or CEL, as readable as possible as you can make it. And this is really important because also policies that are written as code can then be stored in version control. And we've all probably heard of GitOps and are practicing or looking to start to practice GitOps. And so it's a really important thing that we can have policies that are reviewed and versioned and tested along the way, just like the rest of our software, right?
I was going to say, when you were talking about manual policies or policies in Excel or rules in Excel, honestly, the most common thing I see is nothing.
Yes, that is
Right? Just nothing at all. Whatever happens to be in the cluster is, I guess it's okay. And that is terrifying.
it is, and also a counterproductive when you're moving into or adopting Kubernetes and you start to scale things out, right? Because
Yeah.
then your problems that you don't even know about start to scale out immensely also. So policy as code becomes much more important when you start to move into this type of space. Um, Another cool thing about policy as code is that once you've defined some policies, those can automatically be enforced across different environments. So whether you're deploying to development or staging or production, those exact same rules can apply consistently. So that gives you a good idea of what's going on at every single stage of your delivery cycle. And then just like code, policies give us consistency and they make things much easier to audit along the way. So we can achieve a much more reproducible compliance along the way, and maintain complete audit trails as we move on to better understand what's changed, when it changed, why it changed, and make better decisions. So, why do policies matter? Policies in general provide standardization at scale. So, again, as we were saying, if you're moving into a Kubernetes scaled environment, standardizing things at scale becomes super important. Really important. There's some really basic things that folks don't think about when you're starting off and you just have one cluster. And so you put whatever labels on things and they make sense to you. But then all of a sudden, the whole point of adopting this technology is to scale. And next thing you know, you've got hundreds of people who are labeling things 1,000 different ways. And to be able to troubleshoot that without any type of standardized naming convention, for example, can become quite difficult to do. So that's the first thing. We provide standardization at scale to ensure your configurations are consistent, that your clusters, your environments, everything is working under requirements without too much human oversight.
If I could jump in there for a second as
For
well.
sure.
I remember when I was fairly new to Kubernetes, I remember somebody talking about the whole labeling thing. And it did not make any sense to me that labels would be a big deal in Kubernetes at that point, because I was very, very new to it. And then, of course, I came to understand that labels, for example, hold your services and deployments and pods together.
Mm.
And I cannot tell you how many times I have had to do things like pull a deployment so that I could go and carefully read all the stuff to figure out which label was applied where. And, oh, wait, you mean this deployment is actually selected by two different services? Oh, great. Is that intentional? Is that not intentional? So, yeah, it's one of those things where I feel like labels all by themselves are one that are um, often not understood as being as important as they actually are.
Yes, I think in general, there's so many components and things to learn, and especially because this is a 101 talk, there's so many things to learn as you're moving into Kubernetes just to get something deployed and working the first time, that until you start scaling, you don't realize the importance of some really basic things. And so obviously we are big proponents of the earlier you start using policies, when you recognize these things, the easier your life will be later on. But that's also a the other reasons that policies matter. We're hearing a lot about platform engineering, folks putting together platforms to be able to deliver a better developer experience, and have developers be in a self-service type of situation. And policies really do help platform teams do that. It allows developers to move much more quickly, deploy things with a lot more confidence, because oftentimes developers don't have context around certain things that have to do with production, right? So they don't always know what CPU limit their application actually needs. This is a very common use case that we see where they just set something because it will work. And then all of a sudden you have a cloud bill, your costs are through the roof. And when an SRE jumps on board to figure out why, it's because you've got a lot of apps running with excessive resource limits, because there wasn't any context. So
Mhm.
this is a very good way to enable your developers by giving them a certain set of just basic guardrails and rules that are easily enforced and will block those types of scenarios, and give them feedback that they understand and can actually take action to. So other reasons to use policies: they eliminate review bottlenecks. Oftentimes you see teams are reviewing 40, 50 manual security reviews a week. This is a massive amount of reviews to be doing. Obviously it slows things down. That team gets totally overwhelmed. So you can eliminate a huge amount of reviews that are typically manual by just putting in some basic policy checks to validate things instantly and get rid of those review processes. And then obviously governance. I think this is one of the reasons that people leave policies for a very long time and don't use them. There's nothing that sounds exciting about governance. It's not, you're not interacting with the Linux kernel. You're not deploying some super crazy thing in a bunch of different times. You're not doing anything that sounds really exciting for most techie folks.
I would like to disagree with you about that, but I really can't.
I'm glad somebody disagrees with that. I so often hear from our community, governance, you can just see as soon as you say the word, people's faces are like, they just totally glaze over.
Really? Yeah. Yeah.
Oh, governance, that's a different team. That's typically the response. Oh, we have a security team. We have another team for that. which is great. But also those teams are then going to come in and try to put some regulatory compliance on your team. And it's much easier to avoid having to talk to people who find governance exciting by just using some basic policies to not then have to talk to them, because you can just send them a report and show them that some basic organizational standards are already there in your delivery cycle.
You're also much more likely to get governance and related things that you want as opposed to things that they want. And yeah.
And that's super important. It's really important that people are dealing with things that have context around what they do, right? And instead
Yeah.
of just somebody external coming in without context around your day-to-day or what's business critical and putting something in, it's much better that teams decide on their own what needs to be enforced. So
Yep.
I love this is such a cheesy slide. So please excuse my mom joke here. But it says start your engine because Kyverno is a policy engine. So this is why we are starting our engines, and it's cheesy, and I love cheesy. So thank you.
That's it. Not inviting Courtney back. Oh, sorry. Was that my outside voice?
I love that you laughed as soon as I said it. So Kyverno is a policy engine. And the advantage of Kyverno specifically for people who are in Kubernetes is that it was originally designed specifically for Kubernetes. So it's a Kubernetes-native component, which means it runs inside your cluster. It works with Kubernetes resources directly. So everything is a CRD or YAML file. There's no external databases or complicated integrations or other things that are needed in order to run it. It supports multi-stage executions, so it's not just run at admission time when your resources are created or updated. You can also run it in the background as a scan. You can run it in CI/CD pipelines. You can even run it in infrastructure as code workflows. So that gives it a lot of adaptability and a very broad range of use. And then another very cool thing about it is that it has familiar syntax. So we all must be YAML lovers, and cell lovers, as we all know, like Flynn. So these are languages, at least YAML, it's not adding another layer of language that you have to learn to be able to use it. And common expression language is something that we see Kubernetes starting to use. We'll talk about it a little bit more later on, but these are advantages of using a policy engine like Kyverno.
And as much as you are not going to hear me breaking out the pom-poms to cheer for YAML and cell, I would rather have a small number of widely adopted standards than 47 different languages, one for each individual tool. So
Absolutely.
yeah, better, it's better to have a standard than to have no standard, even if your standard is not perfect.
Yes, this is also in parallel with the conversation we were having about labels, right? It's better to have a few that
exactly.
are clearly thought out and work than to have 1,001 things that aren't standardized at all.
Yeah, there are some places where it's better to save your creativity for creative solutions to problems rather than things like syntax and where you put the curly braces in C programs and things like that.
Yeah. So that's how you can start your Kyverno engine. We can take a look at architecture. I think I actually added 2 slides here because the first one was just a brief overview. But I did add in our actual architecture from our docs. But if we walk through Kyverno very quickly, for starting with the basics, when a user or even a CI/CD pipeline is going to interact with your cluster, they're really talking to a Kubernetes API server. So every action, like creating a pod or updating a deployment, first goes through an API server. And then before that request is accepted and stored, the API server then calls out to a registered webhook. and Kyverno registers itself as one of those webhooks. So we won't deep dive into webhooks because we have two different types, and that would take some time. But you can find more information about those in our documentation if you're interested. Once it does that call to the webhook, this is where the admission controller comes in. So API servers send that resource payload to a Kyverno admission controller, and then Kyverno basically decides what to do with that call. So if somebody tries to deploy a pod without a CPU limit, for example, Kyverno can then deny that deployment or also mutate the resource to add those limits automatically by just employing the policy at admission. So that's a simple example of how that admission controller works. And then behind the admission controller is the actual policy engine. So that's kind of the brain or the core of the system. And the engine evaluates resources against the policies that you created, and then decides whether to validate or mutate or generate or validate images or clean up your environment, which maybe we'll see later, or maybe we won't. Then verify all of those different things. And then also it includes background controllers. So those background controllers scan existing resources over a period of time, and they can ensure continuous compliance because they're constantly running in the background. So even if something changes at creation, Kyverno will actually catch it. So and then to wrap that out, the general architecture ends with policy reports. So we do have policy reporting built into Kyverno. We're also actively contributing to the open reports, open source project, because some people love our policy reports and other folks want to have additional reporting. So that's pretty much where that cycle would then start over again, is once you get your policy reports. So these are just to provide visibility around your policies, as whether they passed or failed, and if they failed, why.
One of the fun things about doing Service Mesh Academy is that it requires me to go and learn about whatever we're talking about, right? And I am not going to lie, before doing this one, I did not know that policy reports were a thing that existed.
Oh,
Much less a standardized thing from a working group across the whole ecosystem. So that was kind of fascinating. Like, wait, what is
yes.
this? Yeah.
There was an entire working group, the policy reporting working group, and then that has now turned into an entire open source project that quite a few folks from different projects participate in, called Open Reports, which
I
is
was just about to ask if that.
well,
Yeah. Okay. Cool.
yeah, Open Reports. I think the first version released about 4 or 5 months ago. And it is, I mean, there are now thousands of users in a very short period of time starting
I
to
mean,
use
it
open.
makes sense in a lot of ways, right?
Yeah,
The ecosystem as a whole functions best when you can have a bunch of different tools that are playing nicely with each other. And it's kind of like governance, where there are people who don't get very excited, but yeah, defining the standards for how the different pieces communicate with each other and with the humans using them, that's important.
it's super important. And having visibility
Hmm.
of whether things are getting better or worse is also incredibly
Yeah.
important. So and oftentimes motivational, especially again going back to challenges that platform teams have. They're trying to get their developers to do things that maybe they don't have a lot of context around. If they can see, okay, I did this action for 2 weeks and now I have a report that's showing me the actual difference that's making, it
Yeah.
makes it much easier to then get buy-in on things that are important.
So, if you're watching this and thinking, ooh, how can I get involved in Kubernetes? Well, here's an opportunity.
This is a big opportunity. It's exactly right.
And this, I
So
believe, is the block
that is
diagram for Kyverno.
there it is, which I was scrolling through my speaker notes and then realized, oh my gosh, I didn't actually include our architecture diagram. So there it is, and you can see users and the pipeline send their request to the API server, and then the API server calls our Kyverno webhook, and then the Kyverno admission controller intercepts that and evaluates the request, and then you can see the policy engine then kicks in to apply whatever that policy is. And then you have your background controllers there in parallel, and then it finishes up with reporting. So a nice flow.
It's kind of funny looking at this and having PTSD about writing webhook controllers. Let's move it on.
I would like to remind you, when I started the architecture, I clearly stated you can look at documentation yourself if you want to know about webhooks. I'd rather not talk about it.
Yeah.
There's so many reasons for that.
But the thing is, it's actually, they are a really useful chunk in Kubernetes, and there are things that you can do with them that you just really can't do any other way. So yet another piece of infrastructure that gets bad-mouthed a lot, but is very helpful. So
and fundamental for the majority of teams, actually. So
somebody is going to ask in the questions, have you considered making Kyverno, updating Kyverno to use a validating admission policy instead of a webhook? And that we'll wait for somebody to ask that.
We'll wait. Exactly. So now we've gone through architecture. So now we're with our 5 policy types. So with our latest release, Kyverno 1.15, this happened just a few weeks ago, we completed our new policy types. So we now have 5 new policy types. We have validate. So these is very clear what they do. These policies check that your configurations meet your basic requirements. So for example, they ensure that every pod has the right labels or CPU limits, like we were talking about before. We have mutate. These automatically add or adjust different fields and different resources that might be missing and need to be created. So you can actually set a mutate policy that if it identifies that there are certain resources or fields that aren't there, can add them automatically or adjust those fields over time. So for example, injecting some sort of default like security context or metadata, those are simple use cases for a mutate policy. We have generate policies. So these policies create a very simple way to clone your resources automatically. So for example, you might have a network policy, and in that case, your generating policy, every time a namespace is created, can then generate your network policy and add it on. And we have verify images. This is one of the newer policy types, and it is already terribly popular. So these policies check that your container images are actually signed, that they're coming from a trusted source, that they meet your supply chain security requirements. So there you have your pesky security team again, but also having your images verified is super important. And we've seen a huge uptick of use in this policy type. And then finally, we have our cleanup policy. So this policy is meant to remove stale resources that are sitting there, or temporary resources, and you can schedule this policy to run. So you can schedule it every 6 hours, for example. And that helps actually with your lifecycle management, avoids a lot of clutter, keeps things more up to date. So those 5 policy types pretty much help you manage anything and everything you could have going on in your deployments, in your clusters.
Cool.
Yeah. Now, cell, common expression language. Why does this matter? So our 5 policy types have come out, and we've explicitly made them for cell.
Actually, you want to back up for a second and define what cell is and where it came from?
Oh, it's a very good question. I don't know exactly where it came from. I'm sure you do, but it is a common expression.
I'm pretty sure it came out of Google. Oh man, I'm gonna have to go look this up now. I'm pretty sure it came out of Google as I don't remember if it was originally intended to be able to do like CRD validation and such, or if that was just one of the earliest uses. Now I'm going to have to go look this up. But yeah, the idea is that it is a language that is intended to be widely implemented with the same semantics everywhere, so that you can include more complex expressions than you can with YAML, and you can still do them in a way that is reasonably portable and reasonably easy to shuffle around.
That's the idea, in one line.
Yeah. Well, yeah.
Very complex.
Thankfully, there's a way in YAML, at least in most places, where you can also break it up across multiple lines.
Yes.
And yeah, that's a good thing. Readability matters.
Readability matters, and also how complex can you get if it's too short. Sometimes that is actually the best way to deal with complex situations, but Cell is becoming more and more adopted, and we're seeing its adoption in Kubernetes. So Kubernetes and its new validating admission policy and mutating admission policy APIs, they're now using Cell, which is a big reason behind why Kyverno is adopting and moving from YAML policies to Cell policies, is because we want to stay aligned with Kubernetes for future compatibility and their future roadmap. So Kyverno goes even further with cell extensions. So that is where our image verification functions come in. Our resource fetch functions also are all dynamic decisions that are going on in cell policy, and then generator functions for templating different things. So adoption of cell in our mind is that it's going to make policies more expressive and eventually more powerful and more widely used, because since Kubernetes is moving in that direction, folks are already starting to pick that up. So that is why we've made this decision, and why cell is important.
We are definitely seeing more of that in Kubernetes. I first ran across it a lot in CRD validation, where it is very useful and often not written with readability in mind, which is kind of disturbing. But
we have to believe that we'll get there. So Kyverno actually goes beyond Kubernetes, and I do want to pause here and let people know. So there's often this misconception, because Kyverno was initially built as a Kubernetes-native policy engine, that you can't use it anywhere else. And this was true in the beginning. It is no longer true and hasn't been true for quite some time. You can actually use Kyverno in a lot of different places, because policies can now run against any JSON payload, for example. And that can, it can also help you govern your infrastructure and your pipeline artifacts. You can validate Terraform. So that, for example, in an EKS cluster is really important. Doesn't expose your playbook endpoint.
Yeah.
Or your databases. So you can use Kyverno policies not just for Kubernetes, but you can use them in other places. This is a super important thing, because if you're going to adopt this tool, you don't want it to just be used in one place. You want to be able to use it everywhere to make things universal.
But we will be showing it in Kubernetes, for the record.
Yes.
I'm sorry, I don't have any Terraform in the demo. Okay, I'm not sorry.
I was going to say, are you sorry? This is a sorry, not sorry moment.
Pretty much, yeah. There's actually, the demo is kind of intentionally showing a pretty narrow application, a way to get started, which we'll talk more about during the demo, but yeah.
Yes, and it's actually a good idea to start small
yeah.
policy space. Absolutely. So Kyverno is a universal policy engine. You can use it everywhere, but this now begs the question, so what are some example use cases? We've talked about labeling already. This ensures your resources and the ownership of all of them, cost allocation, all of those things can be sorted out and debugged much easier. Naming conventions, again, resource limits. So we already discussed the CPU and memory limits. This avoids a lot of problems along the way. Service mesh coverage, so can ensure that all of your workloads are properly meshed for observability and security.
Which obviously we like.
Yes, it's the way it should be. Authorization policy protections prevents unauthorized changes. This is very important. So, and RBAC policies as well. Everybody should be employing RBAC policy, and Kyverno can help with that. And then certificate security is another thing. So we verify TLS certificates and meet basic security standards and rotate them as necessary. So these are just some very basic practical examples of how your organization can get started with some simple Kyverno policies in real world use cases.
Cool.
And then we've got the advantages of Kyverno. I mean, just to kind of rehash them, it's got a strong foundation with its API machinery and its RBAC system. It's going to enhance your version control and reviewability and testability of different things along the way. It incorporates well into your workflows, comprehensive enforcement, so things become very standard across the entire lifecycle. It has cross-platform governance, so it's going to ensure consistent governance all the time. There's that lovely word again, but it is very
It's important. I mean,
it is. It really is important, and all of those things come together. They just give you a much safer, more compliant, and much more automated platform that scales easier. So that really is the main reason to start using policy earlier on. The more you start to incorporate them from the beginning, safety and compliance are just standards that we need to be keeping in mind always, but also things just automate much faster when you can put those checks and balances in place and they do it themselves in the background.
speaking as someone who has, in fact, had to go through and read YAML things to decide whether they were okay to release and actually apply to the system, I would much rather have a computer doing that.
Yes, right.
So much faster and safer and better. Yeah.
And easier in the eyes.
Oh, yeah.
And trying to find where you sneezed while you were typing a YAML and put in an extra whatever. So yeah, I think it's a good way to go. So where do we start? These are very common questions when people start to just discover a documentation or a project in general. We have a Kyverno playground. It's a great place to start. You can
I'm actually
test.
going to stick up one of the
Yeah.
banners for that because I forgot that we didn't have the URL on this slide. So here you go. There it is. It's really tough to remember, covering my face. Playground.kyverno.io.
There it
The
is.
playground's pretty cool.
It is pretty cool. It's web-based. It lets you try out policies without actually needing a Kubernetes cluster. You can test cell expressions and validate policy logic and change things back and forth from YAML to cell to see which one's more readable.
One of the things I wanted to point out about the playground is that it actually does a better job. There's a command line test as well, which I will be demoing, but the playground does a better job of validating that its inputs are correct than the test command does. And one of the things that was lots and lots of fun was realizing that at one point, one of my tests was failing because my deployment was actually not a valid deployment that I was feeding to the test. And the playground caught that, even though Kyverno test did not.
Did not.
So, yeah. So that turned out to be important.
This is very good feedback.
Yeah, playground's cool.
Playground's cool.
Yeah,
it's doing its job. That's good to know. Another thing that I want to call out here: it doesn't matter how advanced you might be in Kubernetes or anything else, and it doesn't just apply to policy. When you're starting out with a new tool, start off small. Oftentimes you see all these use cases and all of a sudden your mind is blown. You're like, oh, I can apply this and I can do that and I can do the other, and that's fantastic. And yes, you can. But slowly build your way up to it. This is super important, especially for policies
Yeah.
for a bunch of reasons. 3 to 5 policies at most. Start with something simple that's manageable.
Oh, I was gonna say start with 1.
Yeah, also, but don't throw all of this at your team. Don't overwhelm yourself. These things do take some thought to figure out what's going to be business critical, what's going to work for you. You might already know that in the back of your mind, and that's great. But also, you have to understand that you have a team of people, of human beings that want to be able to touch everything, move everything, do everything. And all of a sudden, you're going to be giving them a certain amount of guidance, let's call it that way. But for them, they're thinking, you're tying my hands behind my back and you're not letting me do what I want. And the issue is not that. You want them to be able to move appropriately, but they need to understand why and what the context is, and that the feedback they're getting is actionable so that they then understand that that's empowering them. The smaller you start for yourself and your own learning curve as well in crafting policies, but also to get your team, especially your dev team, on board with having policies and getting them to then participate in the process of crafting and telling you what policies would be useful for them, the better off you are. So pick a couple of smaller use cases that you know you're going to see an impact from, put them in a staging or testing environment, audit them first so that people can then get that feedback, see that it's actionable, ask some questions, understand what's going on, and realize that that's an empowerment for them. Don't just throw them into the deep end, because as soon as you do that, things will become very overwhelming, not just for you, but also for managing a team of people, and also trying to manage all of the different policies that you've crafted, because there is a certain amount of a management that then has to be done. So that's a big one. Start small, build up. Once you start small and you get buy-in and you get your feet under you, you can build those things up very quickly because your use cases become very clear. And once you've gotten a few under your belt, then it's much easier to accelerate that. And I think that goes with any tool, to be honest. I think you should always start small, and then be as ambitious
Yeah.
as you want later on. Common pitfalls. I'm going to repeat the start small again. I know it sounds crazy, but dozens of policies are just too much for teams to get started with. If people get frustrated, they feel like everything, all of a sudden they're not allowed to do anything. So start small, get some buy-in, make sure that they understand what's going on, and then you can gradually scale. Um, don't write too restrictive of policies or rules at the beginning. This is also, you don't want to be too restrictive, because you really do want people to be able to take action in what's going on. If you make things too restricted, it makes it very difficult to then have people be empowered for self-service. So think a little bit about what you want that rule to look like. Don't have it be too restrictive, and always start in audit mode so that you can kind of observe that first impact and then progressively tighten that enforcement as you go. And then finally, don't forget CI/CD integration. This sounds so simple and silly, but oftentimes it gets left out. Policies only run at runtime. You'll clearly catch violations too late. So if you integrate Kyverno checks directly into your CI/CD pipelines, those issues will get caught much earlier on. You get a bigger bang for your buck in terms of the amount of time you've invested to start doing these things. And everything is then much more shift left in terms of not just security and misconfigurations, but also your CPU limits and everything else. So your resource
Yeah.
distribution. If you can catch those things before it hits production, you now save a lot of money. You have things that are much more secure. You have things that are running much more efficiently, and that's better for everyone. And we're just about to the end. We'll wrap it up a little bit and then go into Flynn's demo. So Policy is code. Keep it in mind. It's going to give you consistency and automation. It eliminates manual reviews as you move forward. It's going to ensure that all of your basic rules are actually enforced every single time. And it does all of that for you once you get your policy crafted. We are evolving from YAML to cell, but both are still applicable at this point in time.
I
So
think we're going to show both even.
great. So we can get started with whichever one is more readable for you. Also, we're going beyond Kubernetes. Kubernetes does have some policy admission built into it, and that's fantastic. Those are the basics that everybody needs to cover. But we go quite a bit past that. So ability to force rules across your infrastructure, your pipelines, your JSON payloads, all of those things, and really build out something that's going to scale for you and your team. And hopefully using Kyverno will make your policy crafting a bit simpler to write and a lot more powerful in its execution.
Cool.
Yeah.
Thank you.
Yeah, thank you.
All right. I said we were going to do a really quick introduction to Linkerd. We're going to do a really quick introduction to Linkerd just for people who have never heard of it before somehow. Linkerd is a service mesh. The point is that it provides security, reliability, and observability as an infrastructure layer underneath your application so that you don't have to change anything about your application to take advantage of it. This is important because if you're using Kubernetes, you're probably using a microservices architecture where the building blocks of your application have to talk to each other over a network. The network is fundamentally insecure and unreliable, and you can't really change that because that's how networks work these days. The point of a service mesh is to make that situation better so that you get to rely on communication between your microservices and you get to trust it. You get to trust that you're talking to the right person or the right microservice, and you can see what's going on. Skip this bit, actually. Well, no, I won't, because I do want to point out that there are a lot of meshes out there that work by adding sidecar proxies next to each of your application pods, like most of them. Most of them use Envoy. We do not. We use a purpose-built, ultra-fast, lightweight Rust microproxy, and that turns out to make a huge difference in what we can do. Mostly because for all that people like to talk about the sidecar problem, there's really not a sidecar problem. The problem is with what you run in the sidecar. So if you're running a tiny little lightweight Rust proxy, not a problem. If you're running a side truck, that's a problem. And the point here is that you get to mediate and measure all of the communications happening in the mesh, and that is the thing that gives meshes their real value here. Okay. All of this is important because, and this kind of actually talks about, or gets to both Linkerd and Kyverno. Security, reliability, observability, these things are not optional. You have to have them. Nobody wakes up in the morning going, oh, I think I'll deploy with no security to production. That sounds great. You can either get these things from a mesh or you can get them by writing a lot of fiddly little application code. And yeah, that's not great. So that's the reason for having a service mesh and really for doing policy stuff in general. All right. I'm going to take this opportunity here to point out first that, once again, we have the Kyverno playground. That's a good thing to check out. I'm also going to point out that if you have questions, the workshops channel in the Linkerd community Slack is the place to go. And with that in mind, everybody cross your fingers and let's hope our demo works out politely. All right, I think, let me make that a little bit bigger. So we're starting here with an empty Kubernetes cluster. And we're starting with the Kyverno CLI version 1.15.1 already installed. And the Linkerd client, Linkerd CLI, This is Buoyant Enterprise for Linkerd, hence Enterprise 2.18.3. And once again, if you want to follow along using Buoyant Enterprise for Linkerd, you need to have a Buoyant ID from enterprise.buoyant.io. Go do it. Check it out. It's pretty cool. Given that we have the CLIs installed, we're going to start by first installing Linkerd, which requires us to install the Gateway API CRDs. If you've installed Linkerd before, this is very familiar. Then we're going to install the Linkerd CRDs, and then we're going to install the Linkerd control plane itself. Then we're going to run Linkerd check to make sure everything is working. And incidentally, this will not succeed until all of Linkerd's control plane is functioning. This is one of those points in the demo that always takes just long enough that I kind of worry about whether or not it's going to work. But okay, good. It's working. Excellent. All right. Come on, Linkerd check. There we go. Okay. There's a thing that happens at the end of Linkerd check that is looking around for other extensions to run, and that always also takes just long enough for me to get worried about it. Despite the fact that it's the same way every time I do it, always, it's just like, oh my God, is this going to work? All right, so next up, we're going to install Kyverno. We'll use Helm for this. So first we add the Kyverno repo, update Helm, and then we're just going to go through and install Kyverno. I think the next time I do this, I'm going to have a way that I can start piping in hold music or something.
Elevator music.
Yeah. What's funny about this is that the last time I was doing it, this happened really, really fast. So now it's just messing with me. There we go. Okay. Finally, we are going to install a demo application. We will use the world famous Faces demo, which we're going to install with Helm. And if you've seen any of these, then you will have seen this happen a lot. So Faces, when it comes up, there's a service in the Faces namespace called Faces GUI, and we're going to grab its IP address, and then we can go over and take a look in a web browser. Oh, wait a minute. We're going to take a look in a web browser that was pointed at the wrong IP address, and we can see that, yes, Faces is happily running. This is actually the last time we're going to look at Faces because, like I said, the point here is that we have a demo that is running. We have an application that we can go and use to explore policies, but you know, which application is running is kind of not that interesting for our particular purpose today. Okay, so we're going to see if we can get Kyverno to do anything useful for Faces. And the first thing we will look at is something that Cortney mentioned before of resource limits. So we have here a policy. All of these are cluster policies, which I think are actually date back to being supported in Kyverno 1.14 and prior, just in case anybody out there is not up on 1.15 yet. But this one does use cell. What we're doing here is we have a policy whose name is require pod memory limits, and it has a rule, require pod memory limits, which is going to look at every pod it can find, except for ones in these four namespaces, because we don't really want to mess with system stuff. And what we're basically going to do here, this is kind of starting at the deep end a little bit here. We're going to audit, and this is cell. The purpose here is, first off, this bit at the end is look at the container, check to see if it has resources.limits.memory, and that has a value. This magic question mark in the middle is because maybe resources or limits or memory don't actually exist. And so you're telling cell, this is a conditional thing. It's okay if you get some undefined things in here. Don't panic about it. Backing up a little bit, this bit is going to iterate over the containers that are listed in this object spec. And you notice how these are all the logical ORs here. So either the image starts with ghcr.io buoyant.io proxy, which is to say, this is a buoyant enterprise for Linkerd proxy, or it's an open source Linkerd proxy using either of the ways you can access those, or it has a memory limit. If any of those things are true, this policy will pass. If they are not all true, or rather, really, if none of them are true, actually, since these are ORs, if none of them are true, the thing will fail and we'll go through and pop up a message saying, hey, all your containers that aren't Linkerd proxies have to have memory limits.
And this message is the important part because it is actionable feedback that people can
You
go,
will
oh,
see that.
now I know what I need to do.
Yes, which is kind of cool, actually. I enjoyed that bit here. Oh, the other thing I was going to say is this is an audit policy. If things go wrong, we will get notified of it, but it's not going to try to prevent things from happening. Everything we do in this demo is going to be audit policies. And the reason for this is that you really, really want things to work auditing before you start turning on enforcement. So,
and this is one of those takeaways at the end also. So this is a perfect example to rehash that. That's exactly right.
I'm not actually going to tell anybody how long I spent getting the policies we're going to show to work, because that would be kind of embarrassing. But you know how I was saying earlier that one of the fun things about doing this is that it requires me to go and learn a bunch of things about stuff? Yeah, a lot of learning. So I'm going to be candid here. I don't really know why this is showing up. I suspect it has to do with my version of Kubernetes, but everything works fine, and so I'm ignoring it. But so, oh, that was fast.
That's
Lots and lots and lots of things in the fail column here, right? Because I deliberately set this up so that none of my Phases pods have memory limits, just so we could show off the failure. So yeah, that's awesome. It found things. Things are failing very, very quickly. These are all policy report objects. If we take a look at this first one, if we look at the YAML, the working group for policy for Kubernetes, this is a policy report. There is a bunch of stuff in here, but some things I wanted to point out here are, first off, this is living in my Phases namespace, which is kind of nice. There is a separate thing called a cluster policy report. This is a policy report. Cluster policy reports are basically the same thing for resources that are not namespace scoped. Mm-hmm. The stuff that I'm messing with here is all the stuff I'm messing with here is all namespace scoped. So we're going to be looking for policy reports. A given policy report is always owned by a specific thing. In this case, we're looking at one that's owned by the Smiley deployment. Whoops. So let's just rerun that, shall we? I'm going to do this the cheating way. What you just saw there was me accidentally hitting the wrong thing after it had already finished. Oh, well. Okay. Just pretend that everything worked flawlessly. What I wanted to point out here was something that Courtney said a minute ago. This message is something that the user gets to see. So it's pretty important that that be actionable. It's important that that tell people what's going on. Having a message like validation failed is not a good idea.
Exactly. It's not helpful. It doesn't say why. It doesn't tell them what to do. So whatever message you put in there is terribly important. The more time you take to make sure that it is actionable, the more value your teams are going to see in having guardrails for them, and the more empowered they're going to be to then move ahead much quicker.
I also wanted to point out this bit. We have the owner reference, but we also have a thing called scope. And I will end up later using the scope to show you some stuff. I did that just because it was easier to work with, because the scope is a scalar and the owner references can be not. So it was simplest this way. All right. Now, I want to point out this before I jump back into the demo script. As we mentioned before, you can run these things in audit mode, or you can run them in enforcing mode. Enforcing mode is kind of handy because you can do things like arrange it so that if you try to apply a resource that violates a policy, the apply will fail, which is kind of cool. On the other hand, when you're just getting started with this and you're trying to write policies in the first place, or if you're introducing a new policy, audit mode is a much better plan. You really do not want to set things up such that something is broken, but you can't fix it, because when you try to do the fix, it's violating an incorrectly written policy. Not that I would have gained any direct personal experience with this while putting this demo together. Yeah, not at all. So yeah, start with audit mode. Audit mode is good. The other thing I wanted to point out here was that policy reports, as you probably noticed, they have UUIDs for names, which can make things a little bit weird if you're trying to go and find out, oh, wait, why did my face pod break? Why is that not passing the policy checks? So this is just a quick demo for how you can go and run all these things down. The first thing we're going to do here is we're going to use kubectl get with a JSON path to grab the single pod out of the faces namespace that matches faces.boolean.io/component equals face. That's a label. Maybe we should have some policies in here enforcing standard labels. And then we're going to go through and just grab the name of that pod, because pods, of course, have names that are derived from their replica set, which is derived from their deployment. So you can't just say, give me the face pod. So if we do that, we will get that pod name. Now we can use JQ to grab, you can basically go and grab all of the policy reports, dump them out as JSON, and then use JQ to say, give me the specific item in here where the name in the scope is the face pod that we just asked for, and the kind is a pod. And then we want its metadata.name. And if we do that, we will get a single face report name, which is UUID, and then we can use kubectl describe on that particular policy report, because describe for policy reports is set up so that it gives us something that's a little bit easier to read than just the YAML. But you'll notice it still gives us the message. It still tells us which policy failed. It still tells us that it's a failure instead of a pass. And it still gives us the summary of how things went. Later on, we'll be able to see places where the policy report says that some policies passed and other policies failed. It's not binary when there are multiple policies involved. So the most obvious thing that we could do to fix all of these failures is just to apply some memory limits, right? So I'm going to manually patch my face deployment so that it has a memory limit in the pod template, right? And when I do that, I could also, I believe, just wait for, I think I can just wait for some things to happen, but I'm going to roll out that pod so that things happen more quickly. And if we sit here and watch this for a little bit, we should see one of these things show up. There we go. The face deployment now says it's passing. The face pod now says it's passing. Face 6.5. There should be a replica set report for the face pod as well, but it might be off the bottom of my screen. Oh, spoke too soon. There we go.
There it is. Yeah.
It just hadn't shown up yet. Okay. One other fun thing here is that you'll notice there's still this failing replica set report here. And we will come back to that later. Now, we could go and manually add things to all of these deployments, but hey, we have this policy engine that's supposed to be able to make changes as well as just auditing thing. So it's not going to be a lot of fun to have to go through and, do all this stuff by hand. So instead, let's get Kyverno to do it for us. And the way we will do that is with another policy with a mutate section now. This is, the same structure. It has a different name. The rule has a different name. A couple of interesting things here. One is that this time we're going to act on deployments because pods are controlled by replica sets, which are controlled by deployments. If we just mutate the pod, then the deployment will blow away our change the next time the pod has to start. That's not very useful. Instead, we need to modify the deployment. Likewise, when we get down here, there is a way that you can do this with cell, but that is not what we are doing here. Instead, we're using the non-cell version to show off how we can do a strategic merge patch. And this is basically going to go and we're going to try to add a memory limit to all of our containers. If there are any init containers, we'll do the same thing. And if there are any ephemeral containers, we'll do the same thing there. It happens that the stuff that I'm using right now is only using real containers, normal containers, but why not? So if we apply this, everybody cross your fingers. And again, we could wait for the background stuff to pick up, but we're just going to restart everything because it's faster. And now let's go back and watch our policy reports. Fun fact, you'll notice that all of those pod reports went away because, well, those pods went away. One of the things that I really wish, feature request for Cortney, is I really, really wish I had a way to just tell Kyverno, quick, rescan everything in this namespace for me.
Oh, that's a great feature request, actually.
So let's pick on color. The color deployment now shows that it has, it has two things that are succeeding. There's a color replica set in here somewhere that's succeeded. There's a color pod in here somewhere that's succeeded. So we're seeing lots more successes. This raises an interesting question. Why does the face deployment show only one success, whereas the color deployment shows two successes? I don't actually think that I have this in the demo, but the reason is that the face deployment is showing a success for the requires a limit check, but the color deployment is showing a success both for the add a limit and the require a limit. We added a memory limit by hand to face, so the add memory limit policy didn't have to do anything, so it doesn't show up as a success. That also took me a couple of minutes to figure out the first time I saw it. So, what's up with the old replica sets? This is not exactly a secret, but it is also not exactly a widely advertised thing. When you do a rollout restart and a deployment, the old replica sets don't get deleted. In theory, this is a thing that will permit you to do rollbacks in some magical way that I've literally never seen anyone actually do. If you are watching this and you have seen people do this, or you've done it yourself, yeah, let me know about that. I'd be really fascinated to understand your use case and what you were doing. We are going to ignore this at the moment in the interest of time, and perhaps we will, well, perhaps nothing. I'll go ahead and update the demo and such to do a better job with this later, because we should be able to use a Kyverno cleanup policy to go and clean these things up for us. But like I said, right now we are going to ignore this. So onward. We're going to go a bit of an aside here and talk about Kyverno test. We have shown a couple of policies, and the astute reader or the astute watcher will have noticed that when we apply policies, they've always been a couple of directories down. The reason for this is that the directory structure is set up in a way that works with Kyverno test. So what we have here, we'll pick on require memory limits because it's last. This is the actual policy. These are sample resources that are going to be applied when we test it, or rather, these are sample resources against which the policy will be applied. They're not actually applied to the cluster. And this is a description of what tests to run and what the expected results are. So if we run Kyverno test, then it will go through and it will do all these things where we've got 4 different tests for add memory limits, which all pass. And we've got some others for preventing Linkerd pod injection overrides and some for requiring Linkerd and all this kind of stuff. And they all pass because, I was able to make them all pass. This command is really useful because let's just say that not all of these passed the first time when I was putting the tests together, and leave it at that. It is a very, very useful way to know that your policy has a fighting chance of working when you apply it to a real cluster. We're going to take a look at the one for the add memory limits. This is the test YAML, the description of the test itself. This is the name of the test. These are files containing policies that you want the test command to work with. These are files containing resources that you want the test command to work with. And we're going to look at the add memory limits policy, its add memory limits rule. If we check that rule in that policy against the resource called no resources and the resource called only requests, then this policy should pass. Oh, and both of those resources are pods. This should pass. If we look at the ones with only limits or requests and limits, it should be skipped. I'm also remembering something kind of funny about this test that I think I should probably fix, even though it passes. If we look in here, yeah, you'll notice I said a kind of pod in the test. These are actually deployments. I got that wrong. But so our no resources deployment is just a very stripped down deployment that doesn't contain a resources stanza at all. And then our only requests deployment is a stripped down deployment that has a resources stanza that only has requests. And then we have, we've got one that only has limits and one that has both requests and limits. So that's kind of all there is to it, really. If we run this test here, then we would expect that, and we look back over here, sorry. Whoops, I can't look back over there. Yeah, here we go. Man. So the expectation here is that the ones that do not have limits will pass, and the ones that do have limits already will be skipped, because this is a mutating policy and it doesn't need to mutate anything. And if we go through and run that again, then we would find out that it did the right thing. You can also use result fail to mark things where the policy should fail instead of being skipped. And yeah, this was pretty critical when I was trying to go through and put these things together to have some policies to work with, because most of the policies that I wrote did not, in fact, do the right thing the first time. It's pretty easy to get things wrong. Another thing I wanted to point out here is that a lot of the time running test, then it would tell me that a given resource or a given test had been excluded. And usually that was because I had screwed up a resource type or something along those lines. All right. I've noticed a couple of things pop up in chat, so let me deal with those for a second. First, somebody confirms that cell did come from Google. Thank you. Much appreciated. And there's a question about, in clusters with many pods running the Linkerd proxy, does it make sense to apply a mutation policy to allow the autoscaler to evict pods during scale down? Probably. I mean, I guess I really should have responded with, well, it depends. But
Oh, that is such a senior engineer
Yeah,
response.
yeah. I haven't.
It's always well, it depends, and it does. Yeah, it does.
So a confession. I have not worked a lot with the autoscaler and Linkerd EHA, but my gut reaction is that it probably does make sense if you're using the autoscaler, because allowing the autoscaler to safely evict things while you're scaling down is important, right? The flip side of that one is that there are actually a lot of situations in which the autoscaler is not it may or may not be the case that the autoscaler is a good idea with the Linkerd control plane itself. If so, part of the question here is, I think it probably does make sense outside of the Linkerd control plane, but that's actually kind of a fun one. We should go and do a Service Mesh Academy where we dig more into stuff like that. So, all right, if you have more questions, bring them on. I can answer them with "it depends" too. Okay, getting back to policies after our digression to Kyverno test. When we installed faces, we did not actually mesh faces into the Linkerd mesh. And we can tell because there's only one container running for each of these pods. It would be reasonable to have a Kyverno policy that demands that things actually be included in the mesh. I have such a policy here. For those of you following along who want to use open source Linkerd, this is the place where you have to change things. There's also a policy in there called require Linkerd instead of require bell. The require bell policy is going to look for the Buoyant Enterprise for Linkerd proxy containers. Require Linkerd will look for the open source policy containers. You could obviously write a policy that looks for all of them. I just decided to split them. Because if you are running Buoyant Enterprise for Linkerd, you probably do not want a pod in your system that is meshed using the open source proxy. It would be very hard to set that up, but it can be done. So I deliberately wanted to separate these policies. So here's my require bell proxy policy. The name of the policy, again, the name of my rule. I found that for my purposes, it was a lot easier to keep these names the same because it made me more likely to understand what was going on. We're going to look at pods. This originally was written for look at pods only when they're created or when they're updated, and I decided to remove that, at least for the moment. Once again, we do not want to look at system namespaces here, but we're back to cell. Basically, we need to see that in order to pass, we need to see that the pod has at least 2 containers, and one of those containers has to have a container using an image that starts with ghcr.io/buoyant.io/proxy : and then again, our message is arguably a little bit too verbose. I could probably have tightened that up a little bit, but it tells you exactly what's going on. So fine. Kyverno test. Yes. And all of these, I'm not going to actually look at the resources.yaml here, but I've got one with a buoyant proxy, one with no proxy at all. I have one that is only the proxy container. It would be challenging to create that unless you create it by hand, but you could create it by hand, so why not? So yeah, lots of other random things going on there. So let's go ahead and apply it to the cluster and see what happens. We should start seeing a bunch more failures.
This is the
Hey, look, there we go, more failures. Suddenly everything got basically another failure tick up. So we're going to look at our face pod again. This is exactly the same set of commands I ran earlier, but I have to rerun them because I've done a rollout restart since, and so my face pod is now different. That really is an ugly looking command. All right. So First off, we see that, oh, look, our pod must have at least 2 containers, with at least one container starting with being a buoyant proxy. This is the require bell proxy policy, and it failed. Then if we scroll a little bit further down, we can see the require pod memory limits policy, and we can see that that one passed. So that's kind of nice. So we've got one pass, one fail, and that's pretty much what we expected. So it would be possible to write a mutation policy to go through and have Kyverno add the right things for us. I am going to do this by hand today, because as soon as you start talking about a Kyverno policy to do this, you have a question to ask. Are you going to modify the namespace to have the Linkerd inject annotation, or are you going to modify the deployment to have that in its pod template? And only you can answer that question for your situation. In my situation, I want to mess with the namespace, so I'm just going to go ahead and annotate the faces namespace to have the injection deployment, and then I will do a rollout restart again. And this is going to take a second or so longer, because I think because it actually is pulling down the proxies right now. There we go. Actually, that command is wrong. I want to roll all of them. And this is how you know we're doing it live, or something like that. Here, I'm only looking for the pod reports, just because I'm getting sick of always seeing the excess replica sets. So we expect this to take long enough again that it'll feel like it's not going to work, I'm sure. There we go. Hey, but we can see that we now have 2 passes for everything. Yay! Instead of 1 pass and 1 fail. All right. So we are just about out of time for this one. That is your whirlwind tour of Kyverno and Linkerd, and oh my God, there's so much more we could do with this. Like, we could go watch certificates, we could watch authorization policies, we could watch so much stuff. We could also demo what happens if you switch something to enforce mode, and then you try to add a pod, and you will see the thing get rejected. But this is the way I recommend getting started. One policy at a time, take advantage of Kyverno test, make sure you understand what's going on when you apply the policy and things change. I can assure you that while I was going through and doing this one, putting this demo together, there were a great many things that I did not understand at first. So yeah, but it was kind of fun to learn, for sure. Also, I want to point out again the playground, because the playground is an extremely useful tool for doing all of this stuff. I showed Kyverno test. I didn't really show the playground, mostly because it involves some copying and pasting and things like that. And I figured we were going to be running short on time on the demo anyway. But it is a very, very useful tool. In particular, there was one point where Kyverno test was skipping all of my tests on one of the deployments, and Kyverno Playground showed me that the problem was that I had actually not indented the resource stanza correctly. So I was trying to feed it an invalid deployment, and test just kind of went, oh, this is invalid, and silently skipped it. But the playground complained that it was not a valid deployment, and suddenly everything made much more sense. So using both of them is a big win. With that in mind, gotchas. Oh, look, the big gotcha is that sometimes you might need to use both of these. One of the things that I found, this is another feature request, Courtney. Okay. One of the big things that I found while I was going through this is that Kyverno would not always be very vocal when I got things wrong. It would just kind of go, oh, I clearly should not be operating on this bad policy or whatever. And in production, that's great because you probably don't want it to be spewing errors all the time. But when you're trying to develop things, it makes it very challenging. So Kyverno test is a huge win, and the playground is another huge win because you can go through and be trying these things, and also because you can give Kyverno test like extra verbosity flags and the detailed results flag, and that will tell you more about what's going on than just throwing it in the cluster and having nothing happen. Also, there were a bunch of points where I would run into this old problem in computing where computers tend to do what you tell them to. And what you tell them to do may or may not mean what you think it means. So, yeah. Kyverno test, the playground, big wins. Also, another gotcha that I ran into was you do need to be careful about resource types. More than once, I ran into a case where I wanted to examine a pod, but I would need to mutate a deployment. And so I would take my policy that examined the pod, everything was great. Then I would copy it over to another one, modify it to do the mutation, and forget to change it to a deployment type. And nothing would work the way I expected it to.
It's a very detail-oriented process. Once you get all the details straight, then it's a fantastic tool. But this is, again, start small and make sure that you get into the rhythm of what details are actually necessary to make things function appropriately.
Yeah, the devil is very much in the details, and that's a really important thing to remember all the time. Those are the biggest gotchas that I ran into, honestly. So with that in mind, this QR code will take you to a link to provide feedback on Service Mesh Academy itself. We would really appreciate that. It's quick. We promise we take it seriously. It's a big deal. I was using Buoyant Enterprise for Linkerd. You can go and check that out. We highly recommend it. We think it's cool, obviously. We do have Linkerd self-paced courses as well, which we would strongly encourage you to check out. And the next time around, October 16th, we will be talking about managing Linkerd certificates without losing your mind, because we haven't really talked about certificate management in Linkerd for about 2 years, it turns out. And there are lots of ways you can lose your mind with this. So we'd like to help people not do that. And with that in mind, if anybody has further questions, we can probably leave that around for a couple of minutes. Otherwise, thank you very much, Cortney. Really appreciate having you here.
Yeah, thank you for having me. It's fun. This has been great.
I'm just happy the demo worked. All right.
It was a great demo. It was fantastic. Thank you so much for doing this.
Yeah, thank you for being on. We'll have you again sometime, I'm sure. All right, let's go ahead and wrap it up. If you have questions after we wrap up, drop them in the Slack channel anyway. We'll get to them. Thanks much. See everybody in October. Have a good one.
Bye-bye.